So in previous segments, I showed you how to convert from a binary number or a hex number into decimal. That's actually fairly easy. You just follow the recipe of what those positional representations mean. Now we need to do the slightly harder thing, is go backwards. We need to take a decimal number and translate it into, let's say, binary. So I'm going to, again, remind you that you sort of know how to do this by converting a decimal number to a decimal number, which seems silly, but hang with me. You'll see the procedure, and then we'll replace of the initial number with something more interesting. So let's say we had the number 748, base 10. And we want to convert it to another base, which in this case is base 10. So what I'm going to do is I'm going to divide this number over and over and over by the base I'm converting to, 10 in this case. So if I take this and divide by 10, I get 74 with a remainder of 8. And that's that number right there, obviously. Then I take this number and I divide it by 10. So now I have 74, I divide it by 10, and I get 7 with a remainder of 4. And hopefully you're starting to see the pattern. Then I take, sorry, there wasn't that number. It was that number. I take this number, 7. I take 7, and I divide it by 10, and I get nothing. Hey, I'm done. And the remainder was 7. And what I get, therefore, is this is the most significant digit, and this is the least significant digit. And I know exactly which digits they are because I divided by 10 once, twice, 3 times to get once the 8, and the second time the 4, and the third time the 7, and that corresponds exactly to the positions here. So this tells me that my number is indeed 748, base 10. Now that seems silly, but the point is, right here, we could replace these by 2's. And when we do that, the number we'll translate to will be in base 2, and we'll do that next.